Solution of Laplace equation in Cartesian coordinate system. We know the Laplace equation, that is del square psi is equal to 0, and del square is the Laplacian operator, that is del square is equal to dou square by dou x square plus dou square by dou y square plus dou square by dou z square. Then this equation becomes, this is the three-dimensional equation, so this equation becomes dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square is equal to 0. That is equation number 1, and where psi is the function of x, y and z. So we have to assume the solution of this equation as psi x, y, z is equal to, because it depends on three variables x, y and z. So x into y into z, and x is the function of x only, y is the function of y only, and z is the function of z only. So that is equation number 2. Now we can dou psi by dou x. What is dou psi by dou x? We know that the value of psi is x into y into z. So dou psi by dou x can be written as y into z into dou x by dou x square. Dou x by dou x. Okay. Now dou square psi by dou x square is equal to y z into dou square x by dou x square. Similarly, dou square y by dou y square is equal to x into z, dou square y by dou y square, and dou square psi by dou z square is equal to x into y dou square z by dou z square. So equation number 1 become, what is equation number 1? So this equation number 1. So instead of dou square psi by dou x square, dou square psi by dou y square, and the third one we can substitute the values, that is yz into yz into dou square x by dou x square plus xz into dou square y by dou y square plus xy into dou square z by dou z square is equal to 0. Dividing this equation throughout by x, y, z, then 1 by x into dou square x by dou x square plus 1 by y into dou square y by dou y square plus 1 by z into dou square z by dou z square is equal to 0. Now we can separate the variables. Okay, here psi is the function of x, y and z. In the previous problem it depends on the u function, depends only on x and y. Okay, here we have three independent variables x, y and z. So first of all we can take this 1 by x into instead of dou square x we can use d square x, because x is the function of x only and y is the function of y only and z is the function of z only. So instead of dou square we can use the ordinary differential equation, that is 1 by x into d square x by dx square is equal to minus 1 by y d square y by dy square minus 1 by z d square z by dz square. Okay, so LHS and RHS part. LHS contain x only, RHS y and z. So each part we can equate to a constant, that is here the constant we taken as k square. So 1 by x into d square x by dx square is equal to k square, that is equation number 3, and this RHS side 1 minus 1 by y d square y by dy square minus 1 by z d square z by dz square is equal to k square, that is equation number 4. Now from 3, that is d square x by dx square is equal to k square x, that is d square x by dx square minus k square x equal to 0. So this is an equation of the equation for damping. Okay, so in this case the solution becomes x equal to c1 into e raised to kx plus c2 into e raised to minus kx. Okay, so you have to remember this solution, the form of the solution. If you get this kind of equation, that is d square x by dx square minus k square x equal to 0, then the solution is like this. It's exponential terms, that is x equal to c1 into e raised to kx plus c2 into e raised to minus kx. So that is the solution, that is equation number 6. Now from 4, this is the equation 4, that is minus 1 by y d square y by dy square minus 1 by z d square z by dz square is equal to k square. Okay, now we have to separate the variables again, because here y terms are there and z terms are there, so we have to separate them. Then we can take this minus k square here, so minus k square minus 1 by z d square z by dz square is equal to my 1 by y d square y by dy square. Okay, we separated these two terms, y terms and z terms. Now what we can do, we can equate each term, that is LHS part and RHS part, to a constant. That constant is here m square. Okay, I take it as a m square. Now the RHS part, that is 1 by y into d square y by dy square is equal to m square. From this, 1 by y into d square y by dy square minus m square is equal to 0. That is d square y by dy square minus m square y is equal to 0. The similar kind of equation we got here. That is equation number 7. Then the solution becomes what? C3 into e to the power ky plus C4 into e to the power minus ky. So this is the solution. That is equation number 8. Now, here is one more term is here. Minus k square. Okay, so minus k square minus 1 by z d square z by dz square is equal to m square. So we can take this part into this side, then it will become positive. Then minus k square minus m square is equal to 1 by z d square z by dz square. Here k square is a constant, m square is a constant. So in combine, instead of this I take another constant, that is n square. Okay, both these two are constant. Then we can substitute another constant instead of this. Okay, so 1 by z into d square z by dz square is equal to n square. Then d square z by dz square minus n square z equal to 0. Then the solution is c5 into e to the power nz plus c6 into e to the power minus nz. So our general solution is psi is equal to x, y, z. Okay, so instead of x, y, z, we can substitute the values here. So this is our general solution. This is the solution of the Laplace equation in Cartesian coordinate system.